Welcome back to the channel. Today's video is from a series on TikTok that I started where I'm going over every function in Excel in alphabetical order. And so in this video specifically, I'll be covering every Excel function that starts with the letter A, which is about 25 functions. I decided that I would combine all of these short clips and post them on YouTube. Even though the aspect ratio is smaller and made for something like TikTok or Instagram, I thought these would be great examples of different functions. And eventually I'd go through every single one and then post a longer video that will go through every single function, including snips of the description and the category of the function, as well as an example on how to use them to hopefully give people some insights of the different functions that are available within Excel. So please leave a comment if you enjoy this type of video, but without further ado, please enjoy the video. Welcome to day one of going through every pre-built function in Excel, which is over 500 functions, and with the first one being in alphabetical order, ABS. So the syntax will be equals ABS, which returns the absolute value of a number. So if we double click on this function, and we can either type a value in here, so let's say negative 100, it will return the absolute value, which will be 100. So let's say we have a 25 and a negative 25. And then if we take this function and then use this value within our function, hit enter, and then drag down to take the other value, for both positive 25 and negative 25, we'll return 25. Since it's taking the distance it is away from 0, disregarding the sign. And this function will be used for exactly that reason whenever you're evaluating numbers and disregarding whether it's positive or negative and only want to know the distance it is away from 0. In alphabetical order, with the second being ACCRINT, which stands for accrued interest, and will return the accrued interest for a security that pays periodic interest. So we can start by typing equals ACCRINT. You can double click. And in order to return the accrued interest with this function, there'll be some arguments or parameters that we'll need to know beforehand before we can fill out this function. And the arguments that will need to be known are listed over here on the left, with the first one being the issue date, which is the date that typically a bond would be issued. And then if we put a comma, the first interest, typically the day when the interest starts accruing. If we put another comma, the settlement date, which is whenever that bond settles or actually gets sold to the buyer. Then if we put another comma, it'll be the rate or the coupon rate, which is a percentage of the par value or the face value that is promised to be paid. So in this case it would be 0.1 or 10%. Put another comma, the par value or face value, in this case 1,000. And then the frequency, which is either annual, semi-annual, or quarterly. We have semi-annual. And then finally the basis, which is typically done on a 30 to 360 basis, which is saying that every month is calculated to only have 30 days, or a 360-day year instead of a 365-day year, to simplify the terms. And once we have those filled out, we can hit enter, and it will return the accrued interest. Similar as today's function will be ACCRINTM, so it will return the accrued interest for a security that pays interest at maturity. So in this case, we have some arguments that we'll need to know prior. So being the issue date, maturity date, coupon rate, par value, and basis. And so if we select the issue date first, then put a comma, then the maturity date or the settlement, then the formula, put another comma, then we have the coupon rate or the percentage of the par value that's promised to be paid at maturity, another comma, then we can put the par or face value. And then finally, the last comma, it'll be the basis. In this case, we're using 0 or 30 to 360, meaning every month has 30 days or a 360-day year to simplify the terms. And whenever we add that and hit enter, it will return the accrued interest for the parameters that we included. Order, with day 4 being equals ACOS, which will return the arccosine of a number in radians. So this will also be known as the inverse cosine. And so the inverse cosine or arccosine is the angle whose cosine is a number. So we need to know cosine, and in this case we have 0.5. So this will return the degrees of the angle, but in radians. So if we want to convert this to a degree, we can use the degree formula or degree function and then select this, and we will get an angle of 60 degrees. And I do have an example to better visualize this. So if we take a right triangle with sides of A, B, and C, with C being the hypotenuse, to find cosine, you would take length of side A, which would be 12.1, divided by the hypotenuse, or C, of 24.2 to find the cosine of 0.5. So then to find the degrees of the angle, or the arccosine or inverse cosine, we would take the cosine of 50, plug that into the formula to find the degrees of 60 for that angle. Yesterday we went over the formula ACOS to find the inverse cosine. So if we type ACOS, there is another formula, ACOSH, which will find the inverse hyperbolic cosine of a number. So the inverse cosine we went over yesterday was to find the adjacent angle. In this case, since it's a hyperbolic cosine, these hyperbolic functions will be used to sometimes graph something like a catenary, which could be something like a chain hanging, and to find the length of a cable or a chain dependent on distance between 2 points. So if we type a number, it has to be greater than 1, so we can put 10. This will return the inverse hyperbolic cosine of 2.99, around 3. And just to show how it's the inverse, if we type cosine h to return the hyperbolic cosine of a number, and then take this number, we will get 10, which is what we included in this inverse cosine formula order. Today's function will be equals ACOT, where we will find the arccotangent of a number, or inverse cotangent, in radians in the range of 0 to pi. So for this, we will need an argument and know a number to plug into this function, which will be the cotangent. For this example, if we take a cotangent of 1 and find the inverse cotangent, if we hit enter, it'll give us that angle in radians. So if we type equal degrees, plug that into the degrees function and hit enter, it'll give us an angle of 45. And to better visualize this, if we take a right triangle and find the cotangent of the adjacent side and opposite side, and then take the inverse of that to find the angle, with it being 45, and since the sum of all the angles will be 180 degrees, and we know the right angle is 90 degrees, we can also say that the other angle in this case would also be 45 degrees. Yesterday we went over the arccotangent of a number. Today we'll be going over the function ACOTH, which will return the hyperbolic arccotangent or inverse hyperbolic cotangent of a number. And for this function, we'll want to plug in a number that is greater than 1 to return the hyperbolic arccotangent of that number. And the equation being applied for this function is as shown on the screen. And the use of this function could be finding the area if you graph the arccotangent and find the corresponding area given the value. And this will be the last function for a little while that deals with trigonometry, so we'll see some use cases of the other categories of functions in the upcoming days. Order. Today's function will be the aggregate function, so we can get started by typing equals AGG, and then we can double click on aggregate. So this function will return an aggregate in a list or database, and there are 19 different aggregate functions that we can choose from within this one function. So this makes it extremely powerful and very useful for working with lists and database and arrays to find the different aggregates that we're looking for. And I'll put on screen the 19 different ones that you can choose from, and in this case we'll just use average. So it'll be 1, we can either type it or click on it within that list, and we can put a comma. So this is telling us whether we want to ignore certain cells and different values within the array that we're going to select. For this case, we can ignore nothing, but I'll show you in a second why that can matter and why it can make it very useful to ignore certain things. Then we'll put another comma. So then we just want to select an array. Then we can hit enter. So this is taking the average of everything in the array that we selected, which was all of column D, or the sale total for each sale. And so a reason why we would want to change that formula to ignore certain cells would be like if we added a certain aggregate right here. Say we wanted to take the first 10 cells and just sum the values of all of these. So we can add another aggregate. We can take the sum, we can put a comma, and we can ignore nothing, put another comma, and then we can just grab the array. So it'll take these first 9 sales and come up with a total of 20,750. But now that changes the aggregate of taking the average of all these sales totals. So if we go back into here, into the second argument, and now we can put a 0. So the 0 will be ignoring nested subtotal and aggregate functions, meaning we already have this one aggregate for the first 9 cells or the first 9 rows. We can just ignore that prior one, and we hit enter. It will ignore this value right here for this row and only take the other applicable rows within this array. So this function is extremely useful for aggregating different variables within your list or database, but also having the capability to ignore certain values. And one more example of this would be if we took another cell and then added, let's say, a value where we divided by 0. Right now, it now has that error in there, but if we change this to ignore errors and the nested subtotals, it will now ignore that error and return the correct value order. Today's function will be address, so we can get started by typing equals ADDRESS, or we could double click on the function, and this will return a reference as text to a single cell in a worksheet. And this will commonly be used to find the reference to a cell that can then be plugged into a formula. So I'll show you a quick example. There'll be some arguments we'll need. So the row number, with 1 being the first row, we'll find this cell right here, which will be the total for revenue for the first 10 days of January. So the row number will be 12. We can put a comma. We know that the column number will be 2 since it's in column B. And this will be if we want the reference to be absolute or an absolute row, relative column, relative row, and absolute column, or just relative. So this means that this cell, whichever way we decide to copy this formula, can change. For this case, we'll just use absolute. Then we can put another comma, and then this will be the style of the address. So R1, C1 means row 1, column 1 style, or A1 meaning like cell A2 or B2 or C2. So we can just go with that. Then we'll put another comma in the sheet. We have a few sheets down here being January, February, and March. So for this case, we could just type a Jan and hit enter. So this address of this cell would be this, and this is mostly used to plug into formulas. So what we mean by that is if we copy this down, then we can put the name of the next cell or the next sheet, which would be Feb. That will return that. And if we do one more to return March, we're returning the totals of the first 10 days of revenue for each of those months. And so now for an example of how we'd plug this into another formula, if we paste this as a value and copy it, so let's say we take the sum of this cell, which is for January, and then we did plus, and we plug in that address and hit enter. It will take the sum of this cell, but will also take the sum of this value. It'd be the same as if we typed sum, took this value, and then either added a comma or a plus, then took this value. So this will be the same exact reference that this cell is referencing right here, except it's absolute values. So if we go back to here, it changes it to Jan, so we want this to be Feb, and we'll get the same exact value. Today's function will be AMORLINC and returns the prorated linear depreciation of an asset for each accounting period. The description for this function does read, returns the depreciation for each accounting period. This function is provided for the French accounting system. If an asset is purchased in the middle of an accounting period, the prorated depreciation is taken into account. So do with that as you will, but the arguments that we'll need to complete this function are as follows. The cost, so we can add in this cell, then a comma, the date purchased, another comma, the first period, the end of the first period, then another comma, the salvage value, then another comma, we'll need the period, comma, the depreciation rate, and finally we'll need the basis, which we could either type or double click. For this one we can use the actual basis, hit enter, and it will return the depreciation for that accounting period for this asset. Today's function will be AND, which returns true if all of its arguments are true. This will be a great video to save if you ever want to look back, as the AND function is one of the most useful functions you can use in Excel, as using logic to find insights or navigate the data is super important. But let's get into an example so you can use this function the next time you're using logical arguments. So we can start by typing equals AND, We can double click. And so the first logical argument will be the test. So for this example, we can just test that this cell is greater than, let's say, 50. So that's the first test. So this will return true if this cell in amount is greater than 50, and this is also true, saying that the sale total, let's say, is over 4,500. So this, of course, returns false, as neither of those are true. And it looks like this one is true, and this one is true, and all the other ones do not meet the requirement of being over the sale amount of 50 and the sale total of 4,500. And the use cases for this function are endless, but I hope this was a nice simple example to get you started. Today's function will be Arabic, which converts a Roman number, or Roman numeral, to Arabic, which will be the numbers that we're accustomed to seeing once they're translated into English. So this function is very simple to use. We can get started by typing equals ARA, and then we can just double click on the function, and then we'll just select the text that contains the Roman numeral. We can hit enter, and this will convert it into a normal number that we're accustomed to seeing. Then we can copy it down, and it's simple as that. Today will be the areas function, which returns the number of areas in a reference. So we can get started by typing equals areas, double click on the function, and then we'll want to select a reference range. So let's say we select these cells and hit enter, it comes back with 1 since we only selected one range. But if we rewrite this formula and then select 1, we can then put a comma, select another group, put another comma, and select a final group. When we do this, we'll want to have double parentheses instead of just one, or else there'll be an error. So we can do that, hit enter, and it comes back with 3 ranges. I do think this function is pretty niche and won't be useful in a lot of cases, but there are some specific cases where, let's say, you're tracking something and have small boxes that are not connected and you want to just count the amount of separate ranges there are, then we could just type areas and then select each of these areas as a way to overall track the different ranges. And there may also be some uses when coding and using VBA, which I'm not aware of. So if you know any, please leave a comment below. And tomorrow I'll be back with day 14. Today will be the array-to-text function, which returns an array of text values from any specified range. So to get started, we can type equals array, and then we can double click on the array-to-text function. And so an array will either be a column, a row, or row and column. So we could return all of these, or we could just return a single row, and we can hit enter, and it will return the first text cell of that array, and then the next text cell with a comma in between. So this could be useful in this case to separate the cities and states. And another thing with this function is if we take the same text as before, but then we put a comma and add 1 being strict, it will format this differently where it's in between curly brackets and parentheses separated by a comma. These types of lists are commonly used for programming in a way to index them. So that could be a use case for this scenario. But this will also take a full column and do the same exact format, as well as taking a row and column, and it will take each value and separate them as well. Today's function will be ASIN, which will find the arccosine of a number. So in this case, if we type 0.5 in this function, hit enter, and then we convert this to degrees, that will give us 30 degrees. And to visualize this, here will be the graphing of the inverse sine or arccosine, and can be used to find an adjacent angle given a right triangle to return the degrees of that angle. Today's function will be ASINH, which returns the inverse hyperbolic sine of a number. So we'll need to know the hyperbolic sine, and then we can plug that in to find the inverse hyperbolic sine. And when we hit enters, we'll return a number. So this has various uses for physics, engineering, mathematics, statistics. And to visualize this, here's a graph of the hyperbolic inverse sine. And I'll be back tomorrow with day 17. Today's function will be ATAN, which will return the arctangent of a number in radians. So for this function, if we plug in the tangent of 1, we can hit enter and it will return the arctangent of that in radians. So now if we type equal degrees, it will convert this into degrees, which in this case will be 45 degrees. They are often used for solving problems involving slopes and angles. And here's a visual example of how we could use the arctangent for calculating the degrees of an angle. Yesterday's function was atan to find the arctangent, and very similar to that one will be equals atan in 2. So there is a arctangent 2 function, which will return the arctangent of specified x and y coordinates in radians between negative pi and pi, excluding negative pi. So if we double click on this function, we will need to provide the arguments of the x number and y number, which will be the coordinates, since this is returning the angle from the x-axis to a line containing the origin 0, 0 to a point with the coordinates of these two numbers. So let's say we put 1 and 1, close the parentheses, and then hit enter. This will return the degrees in radians, but if we type equal degrees, use this function to grab this angle right here in radians, it will return it to degrees. So the syntax for this function is pretty simple. Yesterday we went over the arctangent 2 function, and the day before that the arctangent. So today we can start by typing equals atan h. So today we'll be returning the inverse hyperbolic tangent of a number. So we can double click on this function, and then the number we'll want to plug in, or the argument, will be the hyperbolic tangent. So once we find the hyperbolic tangent, plug it into the number, it will return the value, in this case being the hyperbolic arctangent or inverse tangent. The use case for this would be in engineering with mathematics and physics, or in statistics. And to visualize this further, here's a graphing of the function. Today's function will be equals AVE DEV, which will return the average of absolute deviations from data points in their mean, and arguments will be numbers in this case. So when we double click this function and then add an array of numbers, it will return the average of the absolute deviations of the data points. And the use of returning the average of the absolute deviations in this data set will be to measure the variability of this data set. And this function will be used in statistics for exactly that, to measure the variability of a data set. Today's function is a very useful one, as it is the statistical function average. So we can start by typing equals AVE, and then we can double click on average. So this will take the average of all of the arguments. So we can just take an array, such as in this table, of the total members within groups, and we can hit enter. So it'll average these 10 groups and the members within them. And this can also take the average of different groups. And what I mean by that, if we type equals average again, we can take the first two of this top table, and then if we press and hold control, we can select these two as well, and these two over here as well, while still holding control. It will separate these by commas, and when we hit enter, it'll take the sum of those 6 cells and then divide it by 6. So this makes it a very dynamic way of taking the average amongst various different ranges. Today's function will be average A. As day 21's function was average, there'll be some slight differences between the two. So let's actually go over the average function, which we went over on day 21, and let's take the average of these 4 cells. So in this array, it averages to 17.5, which is really just taking this number 20 and this number 15, and then taking the average between the two. So the difference between the normal average function and the average A function is that it will also incorporate these other cells, not the number within, but we'll still count them within the average. So for example, we'll start with average, go to average A and double click this function. We'll take these values of this array and hit enter. So now we get a different value of 8.75, which will be this 35 of these two numbers divided by 4. So it's also incorporating the other cells even though there's not a value. And also if we just deleted the values within these, it would no longer count them. So as long as something's in any of these, such as an A and B in these cells, they're not blank, so it's incorporating them. But if we change one of these numbers to an actual number being 10, or one of these cells into a number, it would change the values of these as well. And that's the difference between the average and the average A function. Today's function will be average if. The last 2 days we also went over variations of the average function, and this one will be slightly different from those. So we can get started by typing equals, start typing average, and then we can double click on average if. So the syntax for this function will be taking a range. So the range will be related to the criteria. So instead of taking the sales amount first as the range, we'll take this product. Then when we add a comma, we'll want to take the criteria. So within this column, there's only either the values wood or plastic. So we can choose one of these. So we'll just choose the example being wood. Then if we add another comma, the average range will now be the sales amount, or the values that we want to average. So if we hit enter, it comes back with the value of 150. So it'll be these three values that if we look at in this example, the product is wood. And so 450 divided by 3, with there being 3 cases of the product being wood, does come back with the average of 150. And that's how to use the average if function. Today's function will be average ifs. Yesterday's function, we just went over average if, which would return the average based on a criteria. And all that average ifs will do differently is allow you to have multiple criteria. So if we get started by typing average, and then we'll double click on average ifs, the average range will be the amount we're looking to take the average from within a data set. And then if we add a comma, the criteria range 1 will be the first criteria we're looking for. So for this example, having a product of either wood or plastic, we can then add a comma, and for the first criteria we'll look at will be wood. Then we can add another comma. Criteria range 2 could be category. Then if we add another comma, the criteria 2 could be either a tool or furniture, but we'll look for furniture, and then we can hit enter. So this function will be taking this amount and this amount, as they are the only ones that have the product being wood and the category being furniture, and returns the average between these two amounts.